Hello? Hello? You can hear me? Yes? I need to make sure my translators can also hear me. Is good? Very good. Okay. It's very nice to be here today. My name is Mike Amundsen, and I live in Kentucky in the United States. Do we know this, Kentucky? Chicken? It's not so good, right? It's not so good as Korean chicken, right? Chimek? Is this right? Yes, okay. So I work in this group called API Academy, and I travel a lot. I travel 35 to 40 weeks each year. Many weeks of travel. So the best way to find me is online. So this is how you can find me in Twitter and LinkedIn and GitHub if you want to look at the code I'm working on. And I would love to connect with you. I would love to hear from you and learn what you're working on and what kinds of projects interest you and challenge your companies. So please connect to me when you can. So the group I work in, this API Academy, is a rather unique group, a small group of people, 5 people, scattered in various parts of the world. And we travel to events like this and to visit companies all over the world to learn how they are using the APIs and the microservices and all these tools to create great software for their companies. So we collect this information and we share this with you. I will share with you what I've learned over this past year. Also, just recently, last year, we released a book which contains many of these items. It is this book on microservice architecture. And SIA has sponsored a downloadable version of the book. So you can visit this URL and get a free copy of the book. And I would love to have you read it and then respond and help us learn some more. We're working on a new project for next year that focuses on APIs as well, so we will release another one soon. Okay, so there are 2 basic things I wanted to share with you today from what we've learned from companies around the world. So one of them is this notion of how APIs and microservices meet up and match to create great software for your company. So I wanted to talk just a little bit about the business level of APIs. Why are they important at the business level, not the technical level? Also talk a little bit about this microservices and what we learned from companies who do this. And an important element is also design thinking. Thinking about how I design whatever I use. It turns out to be one of the keys to success is good design even of API. And then finally, a pattern of implementing the APIs that has been very consistent in many companies that we visit. So we'd like to share this with you. This is something that you can take with you right away. So I'd like to start with these, and then a little bit later, I will show you some other slides from another learning that we've had that's focused on innovation and how innovation can change how you apply these skills. So I have one more thing I must do before we begin. Because I travel so often, I need what we say is evidence. I need a picture of you so that everyone knows I am not just at home on the beach. So maybe if you can just wave, hello, thank you very much. Okay, now we're ready. Okay. So this idea of the business of APIs. How can APIs change the way we think about organizing our business? So a key element is this definition. Application Programming Interface. The most important word is interface. APIs are the doorway to your company. They're the distribution of your product. Whether it's a bank or an online store or restaurant or a company that sells books online, this interface is how everyone knows you. And inside the company, this interface is how each team interacts with each other. Great interfaces make a great company. Difficult interfaces, where it's easy to make a mistake, means everyone is suffered. So a great interface is very important. We know this because when we design the interface for humans, we know the applications that make us feel happy, that make us feel angry, the applications where it's easy to make a mistake, or the ones that are confusing. So we judge an application by its interface. And the same is true for the machines when we create applications for APIs. So when we make requests and responses, making that simple, making that easy, making it easy to do the right thing, improves the quality of everyone's work, reduces the amount of support and mistakes inside the company. So this is a key way to affect the quality of your company. APIs, we say, help you unlock hidden business value. Especially for companies that have been around a long time. You have lots of data, many databases, decades of learning, all inside your company. The interface is the doorway to allow others to take advantage of your value, of your information, of what you have learned. And there are three key ways to do this. Great API platforms allow you to build new applications on the same infrastructure at a low cost. I don't have to start from the beginning to design the data and design the middleware and design the application. I can simply design the application that uses the APIs. Another thing that great API platforms do is it makes it possible to create new revenue streams, new opportunities. Maybe one of the great hidden values inside your company is all of the transaction data from everyone who visits your website or everyone that owns your product or uses it somewhere. And you can create new opportunities to share this with other companies so that they can learn from your customers and you can serve your customers better. So this could be a new revenue opportunity. Finally, these interfaces may make it possible for you to deliver your product into a market that you don't have access to directly. Maybe a market in Latin America or somewhere in Europe where the information and the data and the experience you have could be valuable. But you don't have a presence in that market. So you can have a partner. The partner can use your APIs and create a brand new opportunity for you. So applications, revenue, and business are all new opportunities with a good interface, a good API. Essentially, these APIs can make interaction easy, whether it's between teams in your company, or you and the customer, or you and the partner. The interfaces make this easy. And making it easy is the key, instead of making it difficult. You want to think about the problems that the customer has and design that API. We have this idea of Clayton Christensen. He writes this book, The Innovator's Dilemma, or The Innovator's Solution, 2 key books. And he describes that when someone buys a product, they don't care about your business, they care about their problem. It's called jobs to be done. So what is the job to be done? I want to hang a picture on the wall. I don't care about a drill. I just want my picture. If I have to buy a drill, okay. If I can do it some other way, that's fine. So focusing your APIs on the jobs to be done gives you a huge set of opportunities to solve the customer problem, no matter who that customer is. So typically in a mobile app experience, mobile apps have really pushed the boundaries of this API space in the last several years. We would have on the back end a server that has all the data, and all the layout and all the graphics, and we would build that page on the server and then send it to the client application. And the client would do just one thing, accept the inputs. The challenge here is for every new device, I must build a new back end. So for iOS back end, Android back end, desktop Windows, desktop Mac, website, I'm building many back ends. Very costly. Not a good interaction model. However, when adopting the interface first, the API first strategy, I can focus just on the data elements. What is the data I need to send? And then I can send it to a client application that handles the layout and the graphics themselves. Maybe this application is built by a partner or by a third-party company that uses your API. The advantage here is once one front end is built, I can now build many front ends with the same API. So the interface becomes the multi-channel platform for all sorts of new opportunities, even opportunities that we can't even imagine today. Someone can build a new interface for my refrigerator, or my toaster, or my car, or my shoes, all sorts of things, and I don't have to rebuild my server. So this is our opportunity to open up new revenue, unlock value at a lower cost to us. So if APIs are the doorway, are the interface, then what do they connect to? And they connect to these services. We say today microservices because this is a popular word. What did we say a few years ago? We said service-oriented architecture, right? Right? But now apparently we're not supposed to say that anymore, so we have the new thing, right? But it's the same idea. So what is the service you provide, and how can we release it into the community? So we spent the last year and a half interviewing many companies about their microservice strategy. What did they learn when they were creating their microservices? What does this word mean to them? So whether it's Netflix online, or if it's Capital One Banking, or Spotify as a music service, or all these other companies, we learned a little bit different from each company. In fact, it was a bit frustrating because they told us different stories. They told us different reasons for adopting this strategy. Some of them said they adopted this microservice strategy to create a product ecosystem. They wanted to create a place where they could build lots of products and release them quickly to a community, even if it was a small community. They wanted to reduce their cost of creating new products. Other companies said something very different. They said they adopted this strategy to create a new set of tools, a new set of platform for other applications in-house. They wanted to make it easier to modernize their system at a lower cost without having to continually rebuild it over and over again. They were building a toolkit. And then finally, a few companies told us the reason they were adopting microservice was to rebuild their system in a more modern way. We say in English, to remove technical debt. Technical debt is old parts of the system that no longer reflect your current business, but we still end up using them anyway. So there's a friction between what we built years ago and what we need today. So each of these were very different and was difficult to reconcile. But one thing all of the companies mentioned was cost. The cost of services, the cost of building them, maintaining them, over time, the cost of connecting to other services. All of these things were a really big challenge, where so many things had to do with speeding up the delivery of software, improving its security. This cost kept mounting and mounting. So they wanted to talk about how they could reduce cost. So when my authors and I, co-authors and I were getting together to decide how to explain this microservice architecture, this is our desk. We were writing all these cards trying to figure out what phrases made sense and how we could turn people who are focused on products and platforms and this remodernizing all into the same place. And what we found as we discussed it more and more were two things. The first thing that came up often was speed. I need to be able to build faster. I need to be able to move, we say, from idea to install in a shorter amount of time. Or some organizations say the phrase, from feedback to feature. When a customer tells us something, how long does it take before we can actually execute? So this speed was very important. At the same time, almost all our customers said that safety was also a big, big value. So it's important not just to speed up, to also become safer, and not just more secure, but to know that the software we're building has less bugs, that the software we're building is more easy to connect without exposing a flaw or a security hole at runtime, as well as easier to secure both identity and access control through the life of the service. So speed and safety. But then another thing comes up. I need speed and safety at scale. I need to be able to do this for many services, for many customers, often at many locations. So this is really the challenge that we all have. And we call this balancing speed and safety at scale. How do you balance the two? In fact, a better word is probably harmonize. Because what we found is organizations that are maybe in a very regulated environment, like banks or health organizations, safety is probably most important. They don't have to necessarily be fast, but they have to be safe first. Some other organizations, like Netflix or some online stores, where the regulations are not the same, they can afford to be a little bit faster because they're not dealing with our health or our bank account. So they make different choices. At the same time, inside an enterprise, the closer you get to the system of record, we say, the database, the mainframe, safety first. Mainframe, it doesn't have to go very fast anymore. We're not changing that every day. But as I get close to the customer with my mobile app, then that is where agility and speed becomes more important. So safety at the foundation, more speed at the top. So the companies that do this well know how to harmonize or tune these two values based on where they are in the organization, where they are in their life cycle. Maybe now we need to focus on speed for a while and then more on safety later. So this is an important element. And all of us, whether you have microservices or not, we all have to deal with this problem. So having a good name for it and a way to think about it can be very valuable. So when we were writing the book, it was explained to us that we must create a definition for microservice. We didn't want to do this. It's too hard. But we worked together, and this is the way we came up with it. I'm not going to read the whole slide, but I'm going to call out one thing very important. Independently deployable. So what does this mean? This means that if your team creates a piece of software that you can release without having a meeting, that I don't have to get everyone from every team together before I can release my software. So independently deployable means that the system already has safety built in so that my deployment won't break somebody. So that's both a design and an implementation requirement. It also means that each team can go at their own pace. So one team, it takes longer for them to complete a job, that's fine. Another team can fix some bugs rather quickly and release them, that's good. So we don't all have to be the same way. We can all move at our own pace. So independently deployable is one of the key steps, one of the key values of microservice. The second important value is the ecosystem in which these services live. We say microservice architecture or infrastructure, and that is highly automated. So we say from check-in of the code to release to production, automate as much as you possibly can. And it is through this automation that you create the safety. We often say this is DevOps, right? Developer operations, DevOps, or continuous delivery, or continuous integration. We have various phrases. But by automating this process, we get rid of variability, we reduce human error, and we increase our confidence and our safety in the final release. Now, before you check in is when I'm designing and when I'm writing the code. That's the creative process. We don't automate that part because that's why we hire great developers and great designers. So they can create beautiful software. But once they check it in, it's our job to make sure that their software is handled properly and consistently in this automation. And this is where the factory begins. You hear CA talk about this idea of the modern software factory. That is the process of molding each piece and making them consistent and easy to fit together. But the creation, the design, that's always going to be the human element. So independently deployable in an automated system is how we call the microservice way. There are a few other things about this microservice way that are worth mentioning. Microservices, this idea of small services, works for large systems, big companies, many teams, many employees. If I have a startup with 5 people, there's no microservices. We just type and we release. It's one service. Okay, so it's micro because we're a small team. But we don't build elaborate systems of microservices when we begin. One of the beauties of a small team is that they can change whatever's necessary without a meeting. What happens as you grow is it becomes more difficult to make those changes without a meeting. So we keep the teams and the service small. So this microservice architecture works when you have lots to manage, lots to deal with. Another big part of microservice is that it is, we say, goal-oriented. What are your goals? What are your principles? What are you trying to achieve? And the goal is always the business value. Microservices are no good unless your business is successful. How can these services help meet those business goals? Why are we making this smaller and not this? Why are we prioritizing this software and not that one? These are the goals that are very important to make sure that we focus on the correct parts of the company. Another feature that we see in companies that do this well is they focus on replacing some existing component, not always adding to it. Those of us who've worked for a long time know when we release the first version, it's very good. In the second version, we add a few more things. It's pretty good. In the third version, we add some more, and it's okay. But we keep adding and adding, and then suddenly, it's this huge piece of software that no one remembers how it works. It's gotten too big. Instead, we see these microservice companies say, this has nice features, but I need a few more. Let me build another one and eventually it will replace this old one, and we'll get rid of it. So we see very many people working on this replaceability idea. And that keeps us from growing software so large that we can no longer understand what the software is about. This is a diagram from the book. It's a bit daunting, complicated, but I think it's very important to mention. You can see from the bottom to the top 3 key areas of focus: modularized, cohesive, and systematized. Each level is a kind of journey in changing the way your IT infrastructure works. So in this first level, this modular level, we focus on that independent deployability we talked about earlier, and on the safety side, the ability to automatically test, automated test. Most of the companies I work with, if they can achieve this first level, they have achieved greatness. Right? They don't need to go further. Their company will get the most value in this first level. Some companies want to continue, and that is the second level, where we are no longer just building a foundation, we're actually designing the services as a family. We have a sort of a view of the way the services will always interact with each other. So we start to change the organization, who's on what team, where they're located, as well as starting to focus on this replaceability idea. I can simply insert a new component and nobody notices. I can change my databases, I can change my middleware, I can change my third-party service, and nobody can tell. So that everything is a kind of a cohesive approach. At this top level, this very advanced level, we're now not even designing the services, but designing the system where the services live. We can select different kinds of infrastructure. We can move from virtual machines to Docker, and nobody knows the difference. We can change the fundamental nature of what we're doing while the system is still running. We don't have to stop. Now, you'll notice this arrow on the far side. So it points to, as you go up, it gets more complex, and that means it also gets harder to manage and more costly. So it's really important to understand this idea that as you move towards the top, it's harder and more expensive. So thinking back to what we said earlier about the importance of business goals, there's no need to be up here unless the business goals require it. I know of only a few companies that are at this level, at the top. Amazon, Netflix, Google, Microsoft, Facebook, global companies. Companies that need to manage things all over the world all the time. Most of my customers don't need that level of complexity to be successful. Here's a trick. At the very top is Netflix movies. They give away most of their software for free because they're at this very top level. They know that the software itself is not the magic. The magic is the way they organize and the people they hire. The trouble is, you can use their software for free, but it's the most complicated software there is, designed for the most complex and advanced kind of network. So it is important to be careful not to just copy another company, because where they are in their journey and what their business goals are may not align with yours. You may end up making things much more complicated very early than is necessary. So we encourage people to focus in this early stage, and usually you can have great success. Testing tools, deployment systems, release automation, system virtualization, all occurs in this very first section of the diagram. So there's lots of opportunity here. It's a great vision for the future. And in the book, we kind of go into each category and what kind of tooling and platforming works in each step. But it's important to have a big picture, we think. And that's why I mention it. Okay. So I want to talk about this idea of design as well. Very abstract idea of thinking about design. Not just for software, but many other things. Because design is what gives us our experience. Bill Moggridge, who is sometimes referred to as the father of interactive design, has this great quote. He basically says, everything that we make involves a decision for design. Even if we decide not to design it, right? We still have to design it, right? So whether it's the phone that has no buttons, that's design, right? Or whether it's my handheld clicker that just has a few buttons and it has green and red, right? We design everything, even to the labels on our bottles, whether this is square or round. Same for software. We design each step of it. And if we don't pay attention to design, we create something ugly, right? We create something people don't enjoy. There are actually 3 key ways to think about design that are worth mentioning today. We say functionality, usability, and experience. From the functionality point of view, it works. It may be a bit difficult or confusing, but it works. From the usability point of view, not only does it work, but it was easy to use. I didn't need a big book. I didn't need documentation. And then lastly, not only is it easy to use, but it's fun to use. I feel good about using it. I feel smarter or prettier, you know, all these things we think about. The experience. If I have white headphones, right, we know that I feel very good because I'm hip, right? I'm the Apple person, right? So all of these come into play. So I want to just talk a little bit about the notion of design with this toast, right? I have toast every morning. I have toast. But toast has various elements. I could just think about the functionality. All I need for toast is fire, right? I could start a fire in my kitchen and make toast. I could go outside and start a fire and make toast. All I need is heat. The problem with this is it's very inconvenient. It'll set off the smoke alarm. It will cause me trouble. So it's not enough that I have the functionality. I need something better. And usually that's this. So now this is usable. It's a toaster machine, and it has a knob to adjust how light or dark. The knob always lies. It's always dark, and it always burns my toast. But this is a much more usable example. So it does more than just create the toast. It does it in an easy way. Toast in, drop it, I can prepare my yogurt and my fruit, and then it's ready, and then I can go. But there's another level. The level beyond usability. Now, I have this fancy toaster that shows the toast to me, and I feel so good about my toast. This is going to taste so good because it looks so beautiful. And I know that it's going to taste good because I paid a lot of money for this toaster. And then I will feel so happy about this. Now I'm actually engineering the experience, right? Not just burning the toast, not just putting it in a machine, but making me just love it so much. Now, it may seem a bit unusual to think about these design elements for APIs, but especially if you want your employees to enjoy their work, if you want your partners to be a part of your world and trust you, and even if you want to gain market from individual developers who are building the iOS or Android app, getting as close to experience as you can really improve your success. So thinking about the design, is this a pleasant design? Is this a design that makes people feel good? Can really be important. Okay, for the last section that I wanted to speak of here is this idea of when we finally want to implement or build or create this interface. We've designed it. I know how I want it to look so that it has the right level of functionality and usability and experience. Now it's time to create them. Now it's important to think about this in a couple of different ways. Remember, we're just working on the doorway now, the interface. The services were built, that's fine. Maybe I have a database inside my company, or I have an ESB that has lots of services. I want to create that jobs to be done API that will solve someone's problem. A problem that they have, not a problem that I have. So I want to design that interface. That means I'll translate the design into technical terms. And these technical terms will be HTTP or REST or SOAP or XML. Those are just translation details. So what I want to show you is a thing that we've learned from companies that we call the three-phase implementation. Sketching, prototyping, and then finally building. Each of these becoming more detailed and more stable along the way. So again, we won't design the actual functionality today. We're not coding the service, just the interface. This means that I can have many interfaces for the same service. So if my education customer wants an interface for content management, I give them one that uses their problems. If my medical company wants to save content, I use their problems. So I design the interface for the same service. You may have the functionality existing in your company. We're just adding the API. You may eventually have to create some of that. Then we'll use the API as a guide. We call this API first, interface first. Design the experience, fill it in later. So just to review, if you already have services, your API becomes the proxy or the gateway between the existing functionality. So we'll find some part of your software, or some microservice component, and we'll connect them with a gateway or some other simple bit of software. If it's a brand new service you're designing, then this is the guide. This will help the people who create the services. They know the interface. Or maybe we're creating just a simple shell or starting place for the new service at some future date. And it may be that when we do the design, there are lots of ways that it could be implemented. So we could convert it into various forms. But the key element is that it's API first and API forever. You can change the code, but once you expose the interface, it's very difficult to change. In fact, we learned from Amazon. Werner Vogels, the CTO of Amazon, said they spend more time on the API than on the code. Because they know once they release the API, millions of people will use it, and you can't get rid of them. They will always use it. Once released into production, it's easier to modify the functionality or the code than it is the interface. Okay, so we're going to translate that design. I won't spend too much time on this part because I want to make sure we cover other things. But basically, translations from the design to the tech are never exact. Just as my translators today have to adjust and retranslate what I say, they come as close as they can, but it's not always the same. And that's fine. we may lose something when we translate is okay, because it happens every day in real life. And if I'm using a SOAP implementation of the design, I will do it differently than if I'm using the CRUD, the create, read, update, delete, rest style, or maybe this new hypermedia style API that Amazon uses, or reactive services like the new Google services. These are all different ways to translate the same jobs to be done, the same design. It's okay if it's not exact. So we're trying to get the best experience we can. So here is how we can do this. We talked about reducing the cost and risk. Using this three-step plan, make sure you find the mistakes early when it's cheap to change, inexpensive to change. So sketching means we can create little experiments that we can throw away if we need to. Prototyping means I can create testable examples that almost look like the real thing, so I can tell if there's trouble. Building means I finally have enough confidence to dig a big hole in a field and fill it with cement and all the girders and everything for the skyscraper, right? This is very expensive. So I should learn all the mistakes first. Hopefully, building the production model is boring because we've discovered all the scary things already. Okay, so the reason for this is that implementations can be very expensive. I have to hire a lot of developers and a lot of team leaders. We have to do a lot of testing and building and testing and releasing, and I have to coordinate lots of parts. So I don't want to make a mistake. I want to learn early when it's inexpensive to change them. Essentially, I want to put off writing the code for as long as I possibly can. If I can, I want to solve the problem without writing any code, which is possible with interfaces. Okay, so I want to talk about this gentleman, Frank Gehry. He's an architect in the West, and he builds beautiful buildings. The building I have here is actually designed for Disney as a theater, as a concert hall, and it cost hundreds and hundreds of millions of dollars to build. So he has to be sure, when it's finally time to build it, that it will work correctly. And to do that, he employs models. Some of these models are actually quite large. You can actually stick your head inside the model to see what the inside of the concert hall looks like, and turn around and see where the stairs are and where the views are and whether or not the light comes in a certain way. So it isn't just drawing, it's actually physically creating these models. And each one of these improves his ability to discover the final production version. And it starts with a sketch, with a simple little drawing. These are Frank Gehry's drawings of the building when he was first thinking about it. And you can see they're very sketchy, very rough. They don't always show all the detail, but it gives you an idea of the relationships and how it might look. Sketching is a great way to begin, because I can sketch several and throw them away until I find the one I like. And sketching APIs works the same way. I want simple drawings. I want to get the general idea, but not the detail. And I can get the basics, but they're just explorations, they're ideas. The API should look like this, or behave like this. The tool that I use for this is an open source product called Apiary Blueprint. It allows me to type Markdown. Do we know this? Markdown? It's a bit like HTML, but it's simpler. And when I type and I say, here's a URL, and here is a payload, a response, then I hit F5, and now I have actually a running version. I can hit that, type that URL and get the response back. It's a little sketch, and I can do this in just a few minutes. In fact, we say you should be able to sketch an API in just a few hours. If it takes you more than a day, then you're not doing it correctly. You're adding too many details. So sketching this little piece of software, seeing it run, means I can show it to my colleagues, to my stakeholders, and say, is this right? Does this look right? Right? So it's very easy. So the apiary editor is what I was showing. There are others that do this in a similar way. I can get feedback relatively easily. I may even be able to use simple tools like a Node.js app or my browser or just some curl, some command line codes to see how the API interacts. So this is my sketch. And I can sketch lots of them. And I can change it easily. Since it only took me a few minutes, if somebody says, no, Mike, that's not correct, and she explains to me how it should be, it's easy for me to change. Oh, okay, you mean this. But if I've spent many days to create this, and I show it to my boss, and she says, no, that's right, I will say, oh, no, I think you're mistaken. I love this very much. I've worked very hard. I think it will be fine. Right? I'm not ready to let it go. And that's a bad outcome for a sketch early. I should be able to let them go. Because, sketches are made to be thrown away. They're just sketches on a napkin at the table. It's fine. So then I find the one or two that seem like they're very good. And that's step 2. That's what we say prototype. So this is a huge sculpture. This sculpture is about 2.5, almost 3 meters tall, and about 4 meters wide. It's a giant stone, and it's chiseled. Well, you don't want to make a mistake. You want to make sure you know how it's going to work before the final copy. And the way artists do that is with a little model. They create a small little model this big and work it all out, all the edges and all the sizes, and get it all worked out first. That's their prototype. And they may even create a few before they get it right. And then they know they can translate it to the big statue. So prototypes help us to figure out all the edges, all the details. They look real, but they're just fakes, like a movie set, right? Like the doors in a television show. There's nothing behind that door. That's okay. But you can work on the details. You can find out all of the edge cases without actually building it all up. You can actually figure out what the security needs to be, what the arguments are, and all the validations that are necessary. It's an inexpensive way to create one that almost works. So this is a way to discover challenges before you get to production, so you don't have surprises. So a tool that many of our customers use is what's called the Swagger editor, or sometimes referred to as the Open API Initiative Editor, or OAI. There are several other products like this, but the details are much more specific. It usually takes a day or two to create an API in one of these prototype tools. We say if you take more than 2 or 3 days, you're probably doing too much, but it will take a few days to get correct. You can use the sketch to start, and then you can get much more sophisticated responses and work out edge cases here. So it turns out CA has a product similar to this. It's called Live API Creator, which is very similar. A unique aspect of their product is that you can actually then mount that as production if it's correct. With some of these other tools, you still have to rebuild. There are lots of other examples like this. At this point, you're building something that almost looks like the real thing, and you may need to connect to other services. So we see many companies using what's called service virtualization. They don't want to connect to the real bank account, but they want to connect to a sort of virtual copy. And often you can include access control, security elements in these prototypes, so you can practice the identity and access control you'll need without a lot of extra work. You may even be able to hook production-level consumers to this prototype so to see how they interact. Instead of just simple tools, you may be able to use versions of your existing consumers. Because prototypes are meant to be tested, and tested often. Because this is where we find all the edges. And once we've tested them, and we're confident on the design, and we're confident on the prototype, then we can build. We can build a real one. And it's usually a very scary experience to build. And it takes many months to build. So we want to make sure that we have it correct. So before we go and dig the hole and pour the cement, we have these prototypes. But now we're on the real thing. We have the access control, the scalability, the resilience, all these other features inside our ecosystem. And that means that we've worked out all of the kinks, all of the bugs, all of the edge cases. We know that we're using each jobs to be done, each use case correctly, because we learned from the sketch and prototype. Now, sometimes this means I will write code when I build. So I have to write a little code to glue things together, or code to access the extra service, or code to even have the mock. This is a bit of Node.js. It's a very simple code. But there are also times when I don't need to write code at all. Because it's just an interface, I can connect to existing services with a policy-driven tool like a gateway. This is much easier than an ESB. I don't have to do lots of other aggregations and if then else. You may also be able to do the same with an ESB, so you can solve an interface without writing code. This can be much easier to work with because it's easier to get that created and tested and built than actually building source code. So it's good to keep in mind. Every way of doing this has challenges. So I might need to write some gateway policy for security. I might need ESB rules for aggregation. I might use some scripting service like Node.js or PHP or Rails. I might even write compiled code like Java or C# or something else. Each level gets more and more costly and more error prone from the top to the bottom. If you can solve the problem early, that's great. Sometimes you may even need a combination. But exhaustive testing for both the unit and acceptance and integration levels is key. And of course, detailed security for access control. But now I can focus on these because I know what that design is going to look like. Because production APIs are made to last. I can change the code, but the API will stay the same. Okay, so to wrap up this first part, we've talked about the idea of how APIs can enable this multi-channel experience, one API for lots of clients. We talked about the functionality, usability, experience pattern, right? It's not just that it works, but that it's usable and that I like it. And finally, we talked about this idea of sketch, prototype, and build to reduce risk, reduce the overall cost, and the chance of making a mistake. And these are the things that we've learned from companies who are adopting this API and microservice approach to lower the cost, lower the risk, focus on the jobs to be done, and build something that can be used in multiple ways. And that's the first section that I wanted to cover today.